Hello guys, this is our third video for this week's work. And so we're gonna start with number 8 and we're gonna go all the way through number 13 because 2 of these are calculator based and you're going to get them right even if you don't do them. Because I realize some of you don't have a graphing calculator at home. In fact, I forgot to bring one home with me, so I don't even have a graphing calculator at home. So for number 8, what we're doing here is they're saying if g of x is 4 times 3 to the x, then what is g of negative 2? So remember, all you do is you're putting negative 2 where the x is. So we want g of negative 2, so we're going to do 4 times 3, and then instead of x, it's to the negative 2. So what I want you to remember is when an exponent is negative, that means that it's unhappy. Remember, it's being very negative because it does not like where it's at. So that means that the 3 should not be on the top. So to make the 2 happy and positive, we have to drop the 3 to the bottom, and it becomes 1 over 3. So we have 4 times 1 over 3 squared. Okay, and then we're just simply going to multiply. Now, I had some students who came to my office hours, and I'm not seeing any of you there, by the way. You should be coming to my office hours. But I had some students who just divided that in a calculator and then squared it and then did times 4, and that works. They got this, 0.444, which rounds to 0.4 repeating. But what I did, I just squared 1/3. So 1 times 1 is 1. 3 times 3 is 9. 4 you put over a 1, and then it's 4 over 9. But 4 over 9 actually still does reduce to this. So any of these answers are correct. Okay, so just remember this whole question was, did you know that the negative 2 needed to replace the x? And then did you know that the negative 2 meant that you have to drop the 3 to the bottom and put 1 over 3 in order to do the problem. All right, let's go on to number 9. Okay, for 9 and 10, we're going to skip these because if you have them, this was an exponential regression. So you have to go and type in your x and y's on those tables and then do the exponential regression and you'll come out with a formula. But if you don't have a graphing calculator, just skip this one. You're going to get credit anyway. For number 10, this one, you literally just type that in. But you can only do log base 5 if you have a graphing calculator. If you hit the regular log button, that's log base 10. So only those students with a graphing calculator, but all you have to do to solve this is literally type in log base 5 of 50. I think it comes out to something like a 2.4, something like that. But again, that one is going to be counted right for everyone, no matter what. All right, so let's go to this one. These get a little bit complicated right here because it's hard to remember those logarithm laws if you're not actually using them every day. So we want to review this, and we're going to review it again after statistics. Our next unit is on statistics, and that's our last new information. And then we're going to start doing a lot of review, trying to keep it to where you understand your learning just to make sure that you have a solid foundation for next year, no matter what class that is, whether it's geometry for you or pre-cal for you. But remember, when we have logarithm problems and we divide, you can separate them and subtract. So I didn't write this, but this is log of x to the 5th minus log of x to the 1/2. Now, why is it 1/2? Because the square root of x is x to the 1/2. The exponent is a 1. The square root means it's automatically a 2. So this would be written as log of x to the 5th minus log of x to the 1/2. Now, the next law says that if it's an exponent, you can roll it to the front. So log x to the 5th, the 5 rolls to the front and becomes 5 log x minus, same thing here, the 1/2 exponent comes to the front and you get 1/2 log x. So this is the final answer, and I could circle that. So this is your final answer. And it's 5 log x minus 1/2 log x. And that's all they wanted you to do was expand it. So you're not solving for anything because we don't know what x is. All right? All right, so let's look at the next one. All right, so the next learning target says, I can factor and solve quadratic equations and inequalities. So I just asked you to factor this completely and then find the zeros. Now remember, you can use box method to factor this, or you can use the slide method. So to use the slide method, we just rewrite this equation, only we slide that 12 to the back and multiply it by 6. So when we do that, and I'm trying to cover all my work here, not that it matters, but I just want you to see it step by step. So here we get x squared plus 17x plus 12 times 6 is 72. So that's what we're trying to factor. So we want to find two numbers that multiply to be 72 and add to be 17. And remember, you can go and put these in and do y equals 72 divided by x, and you'll be able to get all your factors on your calculator. But the two factors of 72 that multiply to be 72 and add to be 17 are 8 times 9 and 8 plus 9. So first we write this. So x plus 8 times x plus 9. However, you got to remember, we had a 12 in front. And because we used the slide method to slide it back, now we have to slide it back into the equation. So we have to divide both of those by 12. Well, unfortunately, neither one divides evenly. We don't get a whole number there. So we just reduce those fractions. I reduce them because it makes your life a lot easier. So 8 over 12 reduces to 2 over 3, and 9 over 12 reduces to 3 over 4, because here you're dividing by 4, and here you're dividing by 3. All right, now, part of the slide method is you have to slide that denominator back to the front. So this 3 goes to the front and gives you 3x plus 2, which is here. And then this 4 slides over there and gives you 4x plus 3, which is here. So that's the first part, the factor completely part. Now we still have to find the zeros. So to find the zeros, you set each one of these equal to 0 and you simply solve for x. So I wrote them each and I have them each set to 0 right there. And then we simply solve them and you get your answer, which is negative 2/3 and then negative 3/4. All right, last one for today's video, and then we're going to also have one last video to cover the last page. But this one says, I can understand and interpret quadratic relationships. Now, this is taking us way back again. So again, this is more about trying to refresh your memory for things that we did so long ago that now we kind of have to make sure you remember. All right, so a circle has a center of negative 2, 7. It's important to note that that is the center. And we also know that the center is HK. That's important. It contains the point 2, 12. Now, 2, 12 is just a point on the circle. 2, 12, right? So we have the point 2, 12 on the circle, and we have the HK. Now, this is the formula for a circle. Again, you might recognize it, but it's x, which we have our xy point here, x and y. This, remember, is the center. The center is always HK. So the negative 2, 7 are the H and the K. They didn't tell us what our radius is, so we're going to have to solve that so that we can do what they want us to do, which is write the equation. All right, so we're going to plug all of our numbers in. So x is 2. Minus h, which is negative 2. So 2 minus negative 2 squared, just copying the formula, plus y, which is 12, minus k, which is 7. So 12 minus 7 squared equals r squared. Then we're simply going to try to solve that. So 2 minus a negative 2 is the same as 2 plus 2, which is 4 squared. And then 12 minus 7 is 5, so plus 5 squared equals r squared. Then you're simply going to square the 4. So 4 times 4 is 16. And 5 times 5 is 25. And that still equals r squared. And then we just add them. And then we don't want what r squared is. Well, actually we do in the final answer. But we go ahead and take the square root of both sides and find r. Now, our original equation needs r squared. So we're actually going to use the 41. We technically could have stopped there. So now all you have to do is take the original equation that I wrote, and all you want to put in is your h, your k, and your r, because you never put your x, y. Think about linear functions. We never put the x, y because that's every x, y. You can't just put one x, y in a final answer. So it's x plus x minus, actually the original formula says x minus h. Again, h is negative 2. So x minus negative 2 is the same as x plus 2 squared plus y minus 7 squared equal 41, which is r squared. And that is the answer for number 13. So I hope this is really helping you. I wanted to use this as a chance to get to refresh your memory. Please, 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 if you can do anything at all for me, I am begging you to tell your friends who are not doing my assignments and who are not logging in. Please, please start doing the assignments. They have canceled the Regents, and if you pass my class, you pass the Regents. Guys, Algebra 2 Regents is the hardest Regents there is, and it's so difficult to pass. But because of what's going on this year, anyone enrolled in Algebra 2 that passes the class automatically passes the Regents. So this is an amazing chance to get that Regents on the record as being passed so that you can get that advanced Regents diploma, because this is the one test that stops a lot of people. So you have a chance of a lifetime, and I'm not worried about any of you who are doing my work because you are passing. I'm very worried about my students who are not turning anything in. And some of your classmates in this elective are fitting into that category. So please, please get them to turn their stuff in. It's so easy to do well. I am begging you to do your work, get it in on time. Ask me if you have any questions. That's what I'm here for. I'm just waiting to help you. I'm doing a lot of help during my office hours. We're going to start going live next week. I think I'm going to be on Wednesdays. So please, please show up and make sure you're getting your work done. All right. So please, please tell your friends. Thank you so much. I'm counting on you. And I will talk to you later. See you soon.